All right, so we are starting Chapter 4 today. Chapter 4 deals with, I just like to give you guys like a run through so you can see ahead what we're doing. We're going to be doing prime factorization, greatest common factor. We're going to be talking about equivalent fractions, least common multiple. Then we're going to be getting into exponents and some of our exponent rules. When we're multiplying two numbers with the same base, what do we do when we're dividing two numbers with the same base? All that kind of stuff. So we're going to be dealing with exponents, and then we're going to end off with scientific notation. So this is kind of a mishmash of a couple things going on in this section. All right. So let's just start with the very first thing. All right. Today is 11:14. And we're going to be talking about factors and prime factorization. So today is 11:14. You guys are on a new sheet a new face of a sheet in your homework or your note spiral. This is 4.1, factors and prime factorization. All right, first of all, what does the word factors mean? Or what are factors? What are factors? Amanda? Okay. Cameron? Exactly. Factors are the numbers we multiply together. So factors go with multiplication, multiplied together to get a product. Amanda, I like what you said though about a factor. Like 2 is a factor of 6. I can multiply 2 by a number and get 6. Or it can divide into it evenly. I do agree with that as well. So when we talk about a factor, we say 2 is a factor of 6 because one reason is because 2 times 3 equals 6, or 2 divides into 6 evenly. What does evenly mean in this situation? When I say it divides into it evenly, what does that mean? Sarah? Excellent. There's no remainder. All right, so I'm not sure how you guys looked at factors last year, but let's talk about how we can use factors in real life. Using factors. How many of you guys are in yearbook? Is there anybody in yearbook in here? All right, so Addie. So when you guys are setting up pictures on yearbook, usually we want to have, when we're setting up pictures on a page, we want to have the same number of pictures, usually, unless we're doing like a fun collage. We want to have the same number of pictures in every row that we're creating. All right, so that's how we use factors. So if we've got 24 pictures, we've got a couple different arrangements of how we can set up those 24 pictures, right? We want to have a certain number of rows and the same number of pictures in each row. That's using factors, okay? So let's kind of explore what I mean by that. All right, so let's use an example. Let's say we are arranging photos for the yearbook. We have 24 pictures, and we want the same number of pictures in every row. So we're setting up pictures in the yearbook. We're going to have rows and columns, but we're having rows of pictures. We want the same number of pictures in each row. All right, what we want to do is we want to determine the possible combinations of arrangements. That's what we want to do. We want to determine the possible combinations of arrangements. I'm going to put a little arrow here because I need to flip to my other page. We need to see what's up there. All right, so we have 24 pictures. We're arranging them in rows. We want the same number of pictures in each row. Are you guys cool with that? Okay. So I'm just going to kind of rewrite that a little bit on my next page so I know what I was looking at. So we have 24 pics. What we're going to do is we're going to use factor pairs of 24 as our number of rows and number of columns. Now in this case, the columns are the number of pictures in each row. So it's going to be the number of rows, the number of columns, where the number of columns, really what that means is the number of pictures in each row. Right, I'm going to show you what I mean by that just with one of our combinations, but you don't have to draw them all. We're just going to list them. Okay? So, well, first of all, when we talk about, we want to arrange this, I'm just going to show you one example, and then we're going to set up a table that's going to help us. So one of them is 2 rows and 12 pictures or columns. So if I was to draw that, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is just a picture. I'm not having you draw them every time, but I want you to understand what that looks like. So I have 2 rows, and I have 12 columns, or pictures, in a row. Can you guys visually see what I'm talking about there? Alright, so what I want you to do, how I want us to organize this better is, I'm going to write here like a table, number of rows, number of pictures in a row. Alright, well, I know one of my possible combinations is 2 rows with 12 pictures. What's another possible combination? Think of your factors of 24. Nico? Be louder, sweetheart. 4 rows, 6 columns. What else? Coral? 3 rows, 8 columns. I like to usually go in order, but I'm going by what you're saying to me. I usually try and go in order so I know I got them all. But we can do it in any order. All right, Matthew? Excellent. 12 rows and 2 columns, because that's different than 2 rows and 12 columns, isn't it? All right, what else? Ada? 6 rows and 4 columns. Brendan? Excellent. 8 rows and 3 columns. Remember, our columns are our number of pictures in a row. What else? Addie? Excellent. We could do 1 row with 24, which seems a little bit long and unreasonable, but we could, right? That's absolutely an option. What else? Addison? Excellent. 24 rows in 1 picture. These are all our possible combinations. All right, now, here's the thing. Some of these seem completely unreasonable, don't they? Right? So I'm just going to put a little note here. Some arrangements seem silly. Right? 1 row, with 24 pictures on it? You're not going to do that on our yearbook, right? All right, so what we may do is we may set restrictions. And these are something that the problem may give you. So let's say the restrictions that are set is we want no more than 10 pictures in a row. So there's our restriction. And you're not setting it. I mean, you would, Mrs. Miracle, for us in our yearbook, she might set it. The editor, if there's a student editor, they may set it just by what they think looks good. All right, but there will be some restrictions set so we can have it look properly, look right. All right, so based on my, I want you guys showing all the possibilities, and then go back and eliminate the ones that don't mean the restrictions, don't meet it. So I want you to list all possibilities, all possible arrangements. Then use a restriction to eliminate arrangements. So I want you to list all possible arrangements, then use the restriction to eliminate arrangements that don't work. Okay, so let's go back up here. I want no more than 10 pictures in a row. Which of these arrangements do not meet that? No more than 10 pictures in a row. Give me one of them, Alex. We want no more than 10 pictures in a row. How many pictures are in the row here? No more than 10 pictures in a row. My pictures in a row are my columns. So I want no more than 10 pictures in a row. I want you to tell me the ones that do not meet that qualification. Are you telling me that 24 rows and one picture in a row that doesn't meet it? This is one picture in a row. We want no more than 10 pictures in a row. So we want everything less than 10. Put your hands down. Everything less than 10 pictures in a row is, we want no more than 10 pictures in a row. Not we want no more than 10 rows. If we want no more than 10 pictures in a row, this is the column that we're looking at. That information is what we're looking at. Not we can't have more than 10 rows. We can't have more than 10 pictures in a row. So the way that this is reason, and I'm glad that you're saying this because I want you guys to understand what this means. 24 rows with one picture in each row. That's what this says. This one says 8 rows with 3 pictures in a row. This says 6 rows with 4 pictures in a row. So, Alex, tell me again. Give me one that does not meet that qualification. Yes, exactly. This one does not because we have more than 10 pictures in a row. What else does not meet it? Patrick? Excellent. That one does not meet it. Do the rest of them meet it? Yeah, so these are all my possible combinations. These are all my possible combinations. So the restrictions, make sure you're going to look at those restrictions to figure out what meet the restrictions. Do you guys understand? What restriction might you also put on this if you were the editor to make this look better? What other restriction might you put on this? Molly? How many of you guys agree that no more than 10 rows is probably a good idea as well? So if I said no more than 10 pictures in a row and no more than 10 rows, what arrangement does that eliminate? Brendan? 24 and 1 and 12 and 2. That eliminates those two, wouldn't it? All right, which might be good, right? That might make it look better. All right, you guys cool with that? Okay, let me give you guys another one that I want you guys to do. So I want you to do this example right here. Can you guys see that in my back row? You guys can see that? Okay. When you guys come in tomorrow, I have new seats for you. So just stand around the room. I forgot to say that to you today. All right, so do this problem, please. Remember, I want you to list all possible combinations and then eliminate the ones that don't meet the restriction. Come on, Danny, get going. Now, one of the things I want you to do when you're setting these up, while we are doing rows and columns, I need you to indicate what the columns mean. All right? Because we're really not doing columns. So state really what the information that columns really mean. When you're done, check with someone seen by you. So answer the question. So when you're done, state what the arrangements are. How many of them are there and what are they? So just like we do with story problems, we're going to state our answer when we're done. I know on that last one we didn't, but on this one we're going to show you. I want you to state your answer when you're done. And don't just say 6 and 6. 6 what and 6 what. Alright, because somebody, pretend that you're the teacher or you're the band instructor and your students are coming in to set these chairs up. If you say 6 and 6, you might not know what that means. So be specific. You're giving directions to somebody. What does our columns mean here? What do our columns mean here? Ada? Yeah, this is the number of desks in a row. All right, what are all my possible combinations? I do recommend that you start with 1. 1 and something. 2 and then something. So be organized with this. Cameron? 1 and 36. 2 and 12. Keep going. Excuse me? Is there a 3? 3 and 12. This is 2 and 18. Thank you. 2 and 18, 3 and 12. Keep going, sweetie. Okay. Excellent. Okay. Okay. Excellent. All right, so now that he's listed all of our possibilities, which ones do we eliminate because they don't meet our qualification of no more than 9 desks in a row? Patrick? No more than 9 desks in a row. Patrick, I need you thinking about what you're talking about. 12 and 3 means I have 12 rows with 3 desks in a row. That does meet the qualification. Which ones don't meet the qualification? So 3 rows, 12 desks in a row. What else? 2 and 18. What else? 1 and 36. So are those all the ones that don't meet it? All right, so how many possible combinations do we have, Patrick? We have 6 combos. What are my 6 combinations? So describe them for me, Patrick. Six rows with 6 desks in a row. Keep going. 9 rows with 4 desks. Keep going. Okay. Okay. If you were doing this, what other qualification would you put on this? And maybe you wouldn't put any. Maybe you wouldn't put any, but what qualification might you put on this to make it maybe more reasonable? Molly? Let's go back and see if that's too limiting. Well, that's only going to give us one possible combination if we did that, right? Right? So maybe we say, who has something different that might make us have a nice, might make us, allow us to have some possibilities, but not, and have them be more reasonable. Valentina? We could do no more than 10 rows. Absolutely, that would limit us to these 3 right here. Yeah. All right, you're going with what they give you, but I want you guys to be like, well, that doesn't, I want you guys to say, well, that still really wouldn't make sense. I think you probably should have something different, but go with what they're showing. How many of you guys are cool with this? Okay. All right, so now what I want to do is I want to jump to prime factorization. So now we're going to be using factors to write our prime factorization. So prime factorization and factors. Now to do that, I need to talk about prime numbers. Because in prime factorization, we use prime numbers. If a number is prime, what does that mean? Number is prime, what does that mean? Cameron? Excellent. It's a number that is divisible by 1 and itself. I do expect you to know all your prime numbers up to like 19, like the very beginning ones, like everything 10 and under. I do expect you to know those prime numbers. All right? Because as we do prime factorization, I need you to know the small ones, 3, 5, 7, 11, 13, not 17, 19, right? So remember those, particularly the smaller ones. All right, so prime factors are any number that's divisible by 1 and itself. If it's not prime, what is it called? Like 2 is prime, 3 is prime, 4 is not prime. If 4 is not prime, what is it called? Nico? Composite. Excellent. Composite numbers. I'm not going to spend a lot of time on those just because I want to talk about prime factorization. In your homework, you may be identifying prime and composite numbers. So what that means is it's a number that is divisible by more than 1 and itself. How many of you guys are cool with prime and composite? Awesome. Okay. So what I want to focus on is our prime factorization. Now last year, I think one of the methods she used was using a birthday cake method. Do you guys remember that? Okay, that only works when you're doing prime factorization for 2 numbers, and I'm going to be throwing variables in there. So what we are going to be using is we're going to be using a factor tree. So we're going to be focusing on using a factor tree only. All right, so let's just do an example. So let's find the prime factorization of 630. It does not matter what 2 numbers you start with. Start with 2 factors of 630. It does not matter. If you see right away 2 factors, use them because we always want to break them down. So what we're looking to do is we're looking to break the number into its prime factors. If you guys remember that. So, give me 2 factors of 630. Give me 2 factors of 630. Amanda? Excellent. How many of you guys saw 10 and 63 right off the top? Well, yeah, because it's a 0 at the end. If you want to take the time and be like, okay, well, 63 is divisible by 9, and we can probably figure what that is, you can take the time. But the first ones you see, easy. If it's divisible, if you know it ends in a 5, try 5. If it ends in a 0, always try 10. All right, now we can break 10 up. What 2 factors do we have of 10? Remember, we want prime factors when we're done. Alex? 2 and 5. Are they both prime? Yep, so I'm going to circle them. You don't have to circle them. I circle them, so when I go back to list the prime factors, I can really easily see them circled. How about 63? What 2 factors do I have of 63? Sophia? 9 and 7? Are either one of those prime? 7 is. How about 9, Sophia? Keep going. 3 and 3. So when we're done, I want you guys to list them out in order. So my prime factorization is 63, or 630, is equal to 2 times 3 times 3 times 5 times 7. This is what how I want you to write it out. So 630 is equal to, and you're multiplying all these. I'm not telling you to multiply it out, but you're showing that it's 2 times 3 times 3 times 5 times 7. All right, and I would like you to do them in order of least to greatest. Because when we do greatest common factor and least common multiple, I want this to be your habit. Questions? Ada? No, I want you listening out just like that. There's a reason for it when we get to least common multiple and greatest common factor. So I want you guys listening. So don't use exponents. That's a good question. Don't use exponents. I mean, there's nothing wrong with it, but for the tool that we're using it for, I don't want you to. You guys cool? All right, I want you to do one more, and then we're going to throw some variables in there. Now, in our answers in the book, they're going to show it with exponents on it, but I want you to leave them without exponents because when we use it, I want it like this. Okay, so I want you to find the prime factorization. of 175. So all you guys do that, please. When you're done, check with someone sitting by you. All right, somebody start this for me. Go ahead, Valentina. 5 times 35. Excellent. Are either one of those prime? All right, I'm going to circle 5. Go ahead. Those are both prime, right? So what's my prime factorization? Excellent. Who did it differently? Coral, what'd you do? Excellent. Yep, so you get the same thing, right? So as you guys can see, it doesn't matter what two factors you start with. As long as you get, when you're done, you get all the way down to the prime factors. Does that make sense to you guys? Okay, so let's throw some variables into this. There's something called a monomial. This is a new term for you, but it's not a new number. All right, so a monomial is a number, a variable, or the product of a number or variables. I'm going to put it's called a monomial. So let me just give you some examples. Like 3 is a monomial. That's a number. X is a monomial. 3 times X times Y is a monomial. 5 times X squared is a monomial. So these are all monomials. It's either a single number, a single variable, or it's the product. Not addition, not subtraction. It's the product, which means we're multiplying. All right, so what I want you to do is I want you to factor the following polynomial. Monomial. The monomial. We'll talk about polynomials next year. Factor the monomial. And it's going to be 28xy to the third. So the first thing you're going to do is you're going to do the prime factorization of the number. So leave the variables off. Do the prime factorization of the number. Somebody do this prime factorization for me. Go ahead, Patrick. Excellent. 2 is prime. Keep going. Excellent. So I have 28xy cubed is equal to, I have 2 times 2 times 7 times x times y times y times y. All right, I do want you to leave that like that. However, we can write it with exponents, written with exponents. Now, I don't want you to for now, but you can, because again, I want you guys, when we get to greatest common factor and least common multiple, I want it written out like this. But if I did write that with exponents, what would it look like? Ada? Excellent. So you can write it with exponents. And it's the product of all that. All right, but again, when we do our greatest common factor and our least common multiple, I want you to get in the habit of writing it out. You guys cool with that? All right, let me give you a couple of these that I want you guys to do, okay? Write them listed out and then write them with exponents. You may do both, but I definitely want you listed out first, not with exponents. Does that make sense to you guys? Valentina? I want you to practice writing them with exponents as well. I want practice of both. I want you leaving it as multiplying it out in order of least to greatest, and then do it with the exponents. Okay. So I want you to find the prime factorization. My first one is going to be let's do 96 W squared Z. And I'm going to put my second one next to it. Someone do the first one for me. Someone do that first one for me. Addison, go ahead, sweetie. 12 and 8, excellent. Excellent, 2 is prime, keep going. Excellent. Excellent. Sweet. Okay, so go ahead and list that for me. So I have 96 W squared Z is equal to, go ahead, bud. So hang on, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Excellent. And how would you write that with exponents, Addison? Excellent. Awesome. Nice job. How many of you guys started different than 12 times 8? All right, did you guys get the same thing? You should have. Absolutely, you should have. Brendan, what did you start with? Okay, so there's 1, 2. So 2 and 48. And what'd you turn 48 into? Are you good? Awesome. Okay. Yeah, you should get the same thing. All right, how about 144? Somebody help me with that one. AJ, I haven't heard your voice yet. Go ahead. Excellent. Okay. Awesome. So 2 times 2 times 2 times 2. Okay. Okay. Awesome. Write that with exponents, sweetie. How many of you guys got that? Awesome. You guys cool with this? Okay. We're all done. So tomorrow when you come in, stand around the room and I'll give you guys some new